Another kind of problems that engineers often have to deal with are problems that are sort of underdefined or ill-defined. Okay? And you will see that most of the practical problems that you will face as engineers will be underdefined. What does that mean? It means that you won't know a lot of input information. You won't be given a model. You won't be given a formula. Okay? And you will have to generate some of the input information on your own. You'll have to make assumptions. You'll have to pick a model, right? However bad that model may be, but it would have to be your first model that you'll use to compute something. And you'll have to report an answer that will be true to some extent, right? It won't be the best answer. So as engineers, if you ever come across an underdefined problem, you should never attempt to solve the problem exactly and correctly, because your answer is going to depend on how good your input quantities are, right? As long as you can make some reasonable approximations, reasonable assumptions about the input information, about the model, and you present an answer, people will be happy. In fact, a lot of interview questions revolve around underdefined problems, like this one. Okay? So this is a problem very similar to the problem that Enrico Fermi used to give to his students, and his original problem is how many piano tuners are in the city of Chicago, right? And this one is similar to that. How many barber shops are there in New York City? So as engineers, we need to be able to solve problems that don't give you all the input information. But if you use some common sense, you can get an answer. So if, let's say, we were trying to solve this problem, how would you solve it? Where would you start? Start with the population of New York City. What do we do then? That's a good starting point. Okay, so we look at how many people are in the New York City. How many people go to the each barber shop? How many people go to each barber shop? Yep, that's the question. That's what we're trying to estimate. Say that again? Oh, percentage. So what he's saying is that maybe we can use some sort of a statistical formula that says that in a given area, a barber shop serves this many people, this much population, and based on that, since we know the population of Manhattan or New York City, New York City is not just Manhattan, of course, we can compute that. So that's a good approach, right? You Google it. Yeah, Google gives you the answer for everything. Right. So you can have some sort of estimate for how many barbershops are in a city block, and you have some idea because a large part of New York City is in grids, so you can estimate how many barbershops there might be. Anybody else? Yes, back there. Sorry? IRS? Ask IRS. I'm not sure if all barbers report taxes. No offense to any barbers, if there are any out here. Yes? Multiply by the total area, right? So you know the square foot of the New York City, and you estimate. So it's almost like the approach he was talking about based on population, or somebody else was talking about the block, right? Yes? Population density. Right. So that's the sort of approach I'm talking about, right? And of course, we can all Google it, no problem with that, and get a very reasonable answer. Maybe we'll Google it and find out really how many barbershops are in New York City. But let's take the approach that he is talking about, right? So he's saying that let's look at the demand side. How much haircutting really people need to get done, right? How many times do you really go to the barbershop? Twice a month? Twice in a month. Twice in a month? You mean every 2 weeks? Really, you go to the barbershop twice in a month? I hate going to the barbershop. Every time I go to the barber, I tell him that I hate coming to you. But I have no choice. My wife, she wouldn't let me in if I don't get a haircut today. I'm very bad with haircut. I mean, I feel is the real wastage of time, just sitting in the barber chair doing nothing while he's working on my hair. So let's take that approach, right? So how many times do you go to the barbershop? And you're a Forget you. Somebody else. How many times do you go to the barber shop? Once every other month? Okay, so once every other, maybe we'll do an average, right? So maybe once every 1.5 months, right? So in a year, you need how many haircuts? 8, right? You need 8 haircuts every year. Now, of course, if you look at the New York City population, it's close to what, 8 million? That's the population of New York City. It's more than 8 million. But let's say we're doing back of the envelope kind of calculations, so an estimate would be fine, right? So 8 million. So not all 8 million people really need haircut, right? Every 1.5 months. I mean, there's so many zombies in there. They don't need haircut, right? Okay, so let's say half of them need haircut, right? So 4 million people need haircut. We have kids, we have women. They don't get their haircut that often, right? How often women get their haircut? Once every 6 months? What? What's the year? Once a year? That's it? Oh, okay. So they're out. So it's just guys, right? So 4 million people need haircut, right? So 4 million times 8, so that's 32 million haircuts every year needed, right? We need 32 million haircuts. So let's do this. We have 4 into 10 power 6 people needing 8 haircuts per year. All right, so that's the demand side. Supply side is barbers, right? So let's say we have n barber shops. And each barber shop has, I don't know, what, 3 or 4 barbers? Let's say 3 barbers. And on any given day, how many haircuts maybe a barber can give? 20? I would think more like maybe 15 or 10. Right. So if you take that, let's say a barber is working for 6 hours every day and is giving a haircut for every half an hour, that's like 12 haircuts, right, in a given day. I mean, of course, the guy has to eat and smoke and whatnot. Okay, so n times 3 times 12, right? So that's on a given day. Then how many days in a year a barber is working? Maybe 300 days, right? So 300 days. So that's per year again, right? So the units are same on the both sides. This is all per year. Okay, you could look at it per month. You could look at it in a decade or 100 years. Doesn't matter. So let's compute this. So what is this? N equal to, okay, let me do this. 4 into 10 power 6 into 8 over 3 into 12 into 300, right? That comes out to 2,962. So roughly 3,000, right? Let's say 3,000. 3,000 barber shops, okay? So how reasonable is that? Sorry. So it was n equal to roughly 3,000. Okay, now let's do what somebody else suggested. Let's Google it. Let's see how close we are to that number, right? I mean, if we get an answer something like 5,000 or 2,000, we're in the ballpark. Okay, so let's see. Where should we Google it? I'll use the yellow pages. Okay, so barber shops. Where? New York City. Okay, how many results? Oh, 3,275 results right over here. Yeah, that's not so bad, right? So, of course, if you use Google, maybe you will get a different answer, right? What? I don't know. New York City, maybe. So that means that if it is only Manhattan, that means since we have estimated for, I don't know, 8 million is the population of Manhattan or for whole New York City, including Queens and Bronx and Brooklyn, Staten Island. Is that the whole or is it Manhattan just? Just Manhattan. So that's it. Then that's good, right? So we are only talking about Manhattan then, right? And that's not so bad. Now, of course, your actual numbers will differ if you change your inputs, right? If you look at your formula that you are employing over here, if you say, I think on average, if you don't have 3, maybe 3.5 barbers in each shop, 4 barbers, and they work actually more than 300 days in a year, and they can actually give more haircuts in a day, right? That means that all of these numbers would increase and would come down, right? And would come down. Of course, this doesn't take into account, certain areas where there may be a larger need because there's a population concentration and stuff like that. But, this does give you some starting point. And nobody would complain if you say, this is my thought process. As long as you talk about your thought process and say, this is how I arrived at this conclusion, people will say, you think logically, and that's enough. I don't need a right answer. I don't need an exact answer, but I want to see what your thought process is.